Okay. Next, some important terms regarding the spherical mirrors. We already discussed center of curvature, radius of curvature, pole, aperture. Let us discuss what is meant by the principal axis. Principal axis. The center of the sphere we can call the pole. The straight line passing through the center of the curvature and the pole is called principal axis. Principal axis. So, we know, let us take this is a concave mirror. Concave mirror. For this concave mirror, we know it has, or like this you have to draw. First of all, take, draw the sphere. This is the center, right? This is the center. If it is the concave surface, it is the concave surface. This is the center of curvature, and this is the pole. Pole means the center of the mirror. Center of the mirror. When we draw a line, that line passing through center of curvature and the pole. Center of curvature and the pole is called principal axis. Is called principal axis. Principal axis. We know what is pole and what is pole and what is center of curvature. What is pole and what is center of curvature, right? So imagine that it is a spherical mirror. It is a spherical mirror. It is the center we already discussed. This is the center. If the light ray is passes through, right? So you observe that small pin also outside. This is called principal axis. Principal axis, which is passes through the center of curvature as well the pole. As well the pole. The straight line which is passing through the center. Through the center and the pole of spherical mirror is called principal axis. Principal axis, right? Then, so the straight line passing through center of curvature and pole of a spherical mirror is called principal axis. Principal axis. So next, focus, or sometime it is called principal focus. Focus or principal focus. Right. Principal focus means the point where all the reflected rays are converge or appear as diverging from the point. Principal focus means the light rays after reflection, they must be converged at a point. Such point is called principal focus, or they appear as diverging from the point. They appear as a diverging from the point. Such such point is called principal focus. Principal focus. For example, for example, for example, let us consider a spherical mirror. Let consider a spherical mirror. A concave mirror, a concave mirror, we know it has the pole and it has center of curvature, a line joining through center of curvature and the pole is called principal axis. So this is the principal axis. If a parallel beam of light, if a parallel beam of light, if a parallel beam of light is incident on the surface. So here one light is incident, here one light is incident, here one light is incident, here also one light is incident. After reflection, we know they reflected. They reflected. So this is the incident rays. Then these are the reflected rays. On a spherical mirror, if a parallel beam of light is incident, if a parallel beam of light is incident, after reflection, all the reflected rays are converged on a principal axis, on a principal axis at a particular point. All the reflected rays are converged at a point which is any point on the principal axis. On the principal axis, such point is called focus. Which point is called focus. The point where all the reflected rays are converged on the principal axis, we can call as focus. So the converging point or diverging point. The converging or diverging point on a principal axis, on a principal axis of spherical mirror is called principal focus, is called principal focus, principal focus. So concave mirror, in case of concave mirror, all the reflected rays are converged on a principal axis. That point where all the reflected rays are converged, we can call the focus. We can call focus. Similarly, in case of in case of concave, sorry, in case of convex mirror. So pole, center of curvature, principal axis, the parallel rays are incident like this, the parallel rays are incident like this. So after reflection, so they reflected like this, because convex mirror convex mirror is a diverging mirror. Convex mirror is a diverging mirror. So that's why all the reflected rays, all the reflected rays, all the reflected rays are appear as appear as diverging from a point, that point where all the reflected rays are diverging, such point is called as a focus. Diverging point of convex mirror, converging point of concave mirror is called as a principal focus. Principal focus. Next one, focal length. It is represented with small l. So the distance or the length, between principal focus, principal focus and pole of a spherical mirror, of a spherical mirror is called, of a spherical mirror is called focal length. The length between, or the distance between focal point or the focus simply, or principal focus from the mirror. So pole, focus, this distance is called focal length. This distance is called focal length. The distance between the focus or the focal point or the principal axis from the pole, distance between the pole and the focus, distance between the pole and the focus is called principal axis. Principal axis. So let us take the summary about these all important points. Let us understand all this with a diagram. So sphere, center, center. Let us consider if this surface is a concave, let us consider this is the convex. Then what is center of curvature? C is the center of curvature. This is concave mirror. This is convex mirror. Concave mirror, convex mirror. Center of curvature, the center of the hollow sphere of a glass, which is the part of mirror. It is part of mirror. It is a sphere. The center is part of this mirror, so it is called center of curvature. This is also center of curvature. Radius of curvature. Radius of curvature. So this is called as the radius. This is called as the radius. For concave mirror, it is inside, it is outside. Then pole. the center of the spherical mirror. This is mirror. Let us consider this is the center. This is the center. Can call it a pole. Can call it pole. Radius, radius. Then, principal axis. The line which is joining, the line which is joining through pole and the center of curvature. Pole and center of curvature, you can call it is principal axis. So, this is a principal axis. Principal axis. Then, next one, focal length. Or before focus, the converging point. The converging point. So, reflected ray, sorry, incident ray, then incident ray, only two take, let us understand very easy. So after reflection, reflected ray first one, reflected ray second one, where they are meet here. So that point we can call as the focus. Here they diverge, here they diverge, these two are meet, right? They are converge here. This is the focus. Then the length between focus and the pole you can write as focal length. This is completely r, this is completely r, radius of curvature, and this is the focal length. Aperture and is the actual reflecting surface is called aperture. It's called aperture. These are the some important terms. These are the some important terms related to spherical mirrors. And we have some relation between radius of curvature and focal length. We have some relation between focal length as well radius of curvature, radius of curvature. Then principal focus and focal length of convex mirror already we discussed here. So they are, in case of concave mirror, reflecting rays are converge. In case of convex mirrors, reflecting rays are diverge. Reflecting rays are converge, reflecting rays are diverge. Now the relation between radius of curvature and focal length is r is equal to 2f. R is equal to 2f, or we can write f is equal to r by 2. That means focal length is equal to half of its radius of curvature. Radius of curvature. If the radius of a concave mirror is 4 centimeters, 4 centimeters, then what about the focal length? 2. So r is equal to 4 centimeters, whereas f is equal to, we know f is equal to r by 2. So 4 by 2, that is equal to 2 centimeters. 2 centimeters. This is about a spherical, this is about a spherical, about spherical mirrors, concave mirror, convex mirror, and some very important terms, and some very important terms. Very easy to understand, no need to much tension. Center of curvature, radius of curvature, pole, principal axis, principal focus, focal length, aperture. Relation between radius of curvature and focal length. ఇంకొంచెం డీటెయిల్ కావాలంటే యూ హ్యావ్ టు వాచ్ మై ఓల్డ్ వీడియో, దట్ 40 minutes ఉంటుంది మొత్తం, రైట్? దిస్ ఈస్ అబౌట్ ది spherical mirrors.